Hello, my name is Victor. I am one of the product managers at GitLab, and me and my team, we are responsible for GitLab's Kubernetes integrations and infrastructure as code functionality. In this series of videos, likely in 3 videos, I would like to demo you how GitLab can help you if you are an infrastructure engineer, an SRE, or if you are a platform engineer who's setting up automations for your teams, or if you have a good platform engineer and want to benefit from their work. Okay, hello. In this third video, I'm going to speak to you how GitLab workflow that we created in the previous 2 videos with a in-code platform, how it looks like for the software developer, for the people who actually own the applications deployed through those projects. Let's get quickly through again what we have spoken already. So we have an Infra Plus platform project where we created the cluster with Terraform, and we have this Terraform project that hosts a YAML file that defines the actual platform managed infrastructure and project. And all of this in the end deploys through Flux, and we can visualize it with the agent. What the Terraform project does is that it creates, for example, this repository here, which we call a delivery repository. And this is where I would like to stop a little bit how we recommend organizing repositories. You don't have to follow this strictly, but in this demo, this is what we actually did. We have a separate application repository and a delivery repository. This means that software developers can use the well-known branching strategies to create a feature branch, merge it to start a merge request with their changes. They could actually even build an image in the merge request, update the respective manifest in the delivery repository to deploy to a development environment, then merge the merge request into the main pipeline, update the delivery repository again to deploy to their staging environment, and at some point tag the repository to build the necessary artifacts and start the necessary process to deploy the application into the production environment. So that's totally feasible, and but what we have seen in the industry is that software development requires a very different branching strategy and update frequency than the delivery code requires. For that reason, we prefer to keep delivery in a separate repo. In this repository, basically everything that matters lives on the main branch because infrastructure is by definition stateful. And this means that we store the manifests for the different environments in subdirectories. And while Flux could read this repository directly with the Git repository source, we are going to use an OCI repository. That's an added layer. You can think about it as it does just caching. You can think about it as it simplifies a little bit developer experience in local development setups. You can think about it that it just scales better because your images are likely much smaller if you only package the files that are needed for a specific deployment, and not the whole Git repository needs to be checked out. And it might be even more stable. For example, if if your Git repository is for whatever reason less stable than your container registry. So this is the setup. We have a separate application repository and a separate delivery repository with the environment, and the actual code. The GitOps repo is this one. Now I will show you how one updates this repository and how it's reflected afterwards in the development and production environments we have. Right now, these two will deploy to the same cluster, just to different namespaces, but this is just because this is demo. So in this repo, as I already said in a previous video, we have the chart. This is the potato head chart without any modifications. And then we have these environments, and within both we have the same two directories. One is a setup directory that can host any Kubernetes resources you need to prepare the environment to be ready for the application. It might be sealed secrets or just references to secrets in whatever external store. It can be additional applications that you want there, sidecars or whatever. And you will likely want to add a resource that points to your application. In this case, we are using OCI, as I already mentioned, so we just point to the same project, to this potato head image, and then we have a customization that goes together with that and requires the whole image. Now, what that OCI, application OCI contains, it contains the Flux resource definition. That's a Helm repository. It's the same chart from this project, again packaged as an OCI container, and the related Helm release. Here you can even use customize and run a customize command in the GitLab pipeline, the customize build that creates you the final Helm release, or you can use another customization, Flux customization in your cluster. It's totally up to you how you structure. I'm here demoing it with the Helm chart. You can see that, for example, here we have replica count 2, and here are the different potato parts configured, while if I go to the development application, then I have a replica count of 1. It's not defined, and we have the same part numbers right now. So this is the basic setup, and together with that is the platform project already set up this project, and even actually the application project. They are set up for us to be able to see the cluster state. We can open the cluster state and see that in production we have 12 running pods, and everything is healthy and reconciled by Flux, while in development we have only likely 6 pods if everything works well. Let's see. Yes, 6 pods, and everything will be green otherwise. The same data exists in the application repository. There I created these dev and production environments by hand, and as we don't deploy from here, you don't really see any deployment data, but you can still see the application status from your cluster. And this brings the cluster close to the developers who might have access already to your GitLab instance, who might be familiar with GitLab, and they can just easily check out these views whenever they are a little bit worried that something might go wrong. Okay, now let's see, how do you update something? Of course, in a release setup, you would likely create a new version in this repository and have that to kick out everything. Now I don't want to change the code and build out the container, but basically in the end, what it ends up with is a change in your manifest. So what I'm going to do, I will just change the manifests here in the delivery repository. You can automate these changes across the repositories through triggers and things like that. What I'm going to do is I will set different, let's use even numbers here, and there is no 6 if I'm not mistaken, so we use 2 and 4 for the development environment, and we will use the odd numbers 3 and 5 for production. And as I'm already in an IDE, I will show you quickly a few things about our pipeline that we run. We will skip the chart because nothing changed there. And then we will skip the entry point as well. What we will run is this dev app job, which just runs every time when we change these manifests. And it will create the Flux OCI image, and it will trigger Flux to reconcile that image. And We do the same with the production, but there it will be a manual job, so the release manager can come in and hit the button whenever needed. Okay, let's update the environment. And what we want to do, we want to commit this to a different branch. Let's say this can be the demo branch. And now we can create a merge request. And what you see now, that this is the tricky part in GitOps, that once you merge something to your main branch, if you watch your Git repository directly, everything gets pulled at the next reconciliation loop, and you don't have real control over the rollout of your GitOps repositories. Now, in this case, we can continue working in the merge request, and once we are done with that, we can merge. And even though we merge to our main branch, it will only deploy to development cluster, because we are building the development image right now. And once it's built, it will immediately go out to the development environment. We should be able to see it here once it arrives. I will update it a couple of times to see once it's there. And actually, we should be able to see it as well under the environments. Let's do it here. Dev and the Kubernetes view. It said already reconciled, but we don't know whether it's the new one or the old one. Oh, it's the new one. Okay. So this is it. Everything changed as expected. But as you can see, now the pipeline is in a block state and the production job did not run. We can see this as well in the production view, that there is a waiting job, and this job is that one. To start it, you should click on this job and then run the job. It's very hard to catch the reconciliation status, that it's just reconciling, so I don't expect that to be able to catch, but once the job is done and GitLab reports that, likely our production changes as well. I guess this is the moment when actually the resources are being rolled out and the service did not pick up the right resources yet. Anyway, you can see the change. So now something happens in my cluster. Things are loading. There we go. So this is in development, this is in production, and simply by updating the delivery, we managed to retain the control over the deployment of different versions into production, while we could automate the deployment to delivery. And we do this with the best practices from Flux, using an OCI registry as a caching layer between your Git repository and your cluster, but it's still 100% GitOps because it's driven by your Git repository. The OCI is not modified outside of Git. It's modified only from in your pipeline based on the status of your Git repository. And with this, the series ends now.